dividing scientific notated numbers. When we have scientific notated numbers, it's always hard to deal with operations because people are really unfamiliar with all of the terminology that goes with scientific notation. Forget about the operations of multiplication and division, addition and subtraction, but we just need to know the terminology that goes with it, and then maybe it makes it a little bit easier. We have now gotten to a place where we hopefully understand that the number in front of a scientific notated number, such as the 8 and the 4, this is our coefficient. And then that small number that's above our tens, or our multiplying of 10, these are called our exponents. Now, what they're asking us to do is take 8 times 10 to the 4th power and divide it by 4 times 10 to the 1st. Now, if this was in standard form, this really would be the problem of 80,000 divided by 40. And all I did was put the place values back with our coefficient. There's 4 place values that go with the 8, and there's 1 place value that's going to go along with the 4. But that's not what they want us to do. They don't want us to divide these numbers in standard form. They want us to divide them while they're in scientific notated form, and I'm going to show you how to do that right now. What we need to do is we need to split this division problem up into 2 sections. The first section, we're going to go ahead and we're actually going to divide the coefficients. So I'm going to rewrite it. Alright, sectioning this off, we're going to take the number 8, our numerator, and we're going to divide it by our denominator, the 4. 8 divided by 4. Any fraction we know is a division problem. How many times can the denominator go into the numerator? In this case, it goes 2 even times, and there's nothing left over, so there's no fraction or decimal left over. 8 divided by 4 is going to give us 2. So that's our new coefficient. How do we find out how many place values we have with our answer? And that's where we look at the exponent. The exponent's going to tell us how many place values we have left, but it's not like multiplication of scientific notated numbers, where we add the exponents together. In this case, with division wouldn't use the same rule as multiplication. It's not going to go ahead and add the exponents. Instead, it's going to tell us to subtract the exponents. And I always tell my students, when we have our exponent that's our numerator and exponent that's our denominator, I tell them to make and connect them with a subtraction bond here. This helps us to rewrite our exponents as 4 minus 1. 4 minus 1. And this is going to tell us what power we have. 10 to the 4th minus the 1st. Our integer rules are going to tell us that we have 4 positives. And our 1 is a negative, so I have 1 negative. And that means I've got more positives than I do negatives. Now I just got to figure out how many more positives do I have than negatives. And I know it's 3. So our new exponent is going to be to the 3rd power. So I'm going to take my coefficient of 2 and my place values that we've stored here. I've got 3 place values that we've stored, and I'm going to write this answer in scientific notated form, and I'm also going to write it in standard form for you. These 3 place values, if we were going to write it in standard form, go along with our 2. So the 2 is there, and I would add in 3 place values. So I would end up with the answer of 2,000. Not too hard, right? Let's get a little more difficult. Alright, not only are we going to have decimal coefficients, but we're also going to deal with double sign numbers, and we're going to have negative exponents that we're going to have to work with. So the first part with this is looking at the coefficients. And when I take a look at these, I've got 1.5 1.5. What is 1.5? Well, I always tell my students to relate everything back to money. What is 1.5 if this was money? And what it is it's $1.50. So we can just put the 0 in there. Make it look a little bit easier for us. And I want to go ahead and take $1.50 and divide it into 3 equal groups. Well, this is easier for me to do in my head now that I got a mental picture of money. 3 equal groups that add up to $1.50 is 50 cents. So I'm going to put that down. Okay, that takes care of the coefficient side of things. Now the exponent side of things. On the exponent side, we're going to go ahead and connect these with a subtraction bond. And we always are going to start with the numerator, whatever exponent that is, and then subtract the denominator exponent. And so off to the side, I can go ahead and write my power of 10. And above it, I'm going to write 1. That's good. And then my minus sign. And then -5. And our integer rules again come into play. This 1, since there's no sign in front of it, that's going to be a positive 1. No problem. But the 5, this is our red flag. We've got 2 negative signs. When we have 2 negative signs in front of a number, what does it mean? It means that that number is going to be positive. So we've got a total of 1 positive and 5 positives, giving us a total of 6 positives. And that tells us how many place values we're storing with our 50 cents. Now, wait a minute. We can't leave this number looking like this because our scientific notation rules tell us that we have to have our coefficient being a number that's between 1 and 9.99. This is definitely not between $1 and $9.99. It's 50 cents. It's less than $1. So that means that I've got to take one of the place values that we have stored up over here and give one of them back. Because when I do that, if I give it a place value, that first of all means that we're going from 10 to the 6th down to 10 to the 5th. And that means that my number becomes bigger by a place value. So instead of 50 cents, my decimal goes between the 5 and the 0, and it now becomes $5. And $5 is a number that falls between 1 and 9.99. And so now this is in scientific notated form. Let's go ahead and quickly put it into standard form since we're here. 5 times 10 to the 5th means that I'm going to want to try to give back 5 place values. And all those 5 place values are going to happen after my 5. So that means I would have 1, 2, 3, 4, 5. And if I put a comma incorrectly, we see that we read this number as, you can read it as 500,000 or 500,000. All right. All right, I got one more for you. Let's see if we can do it a little faster. We've got our coefficient side on the left. We've got our exponent side on the right. I would label that if I were you. And let's start with a little division. Let's see what we can do. What this is telling us is that we have, basically, I'm going to change it back to money again. We have $2, and we want to know how many quarters make up $2. Well, 4 quarters makes up $1, so that means that it's going to take 8 quarters to make up $2. So we would say that the answer to this, 2 divided by 25 cents, would be 8. So that becomes my new coefficient. Perfect. On the exponent side of things, remember, since we're dividing two numbers that are in scientific notated form or close to being scientific notated form, we need to subtract the exponents. So I'm going to connect these with a minus sign, and then I'm going to write my place values over here and my exponents as an integer problem, -3 minus 2. Now let's use our integer rules. The 3, well, that's a negative number because of the minus sign that's in front of it. And the 2 is also negative because of the minus sign that's in front of that, being part of the rule for subtracting exponents when dividing scientific notated numbers. How many negatives do I have altogether? I got a total of 5. So we would say that our answer has 5 negative place values that go with it. Now this is in scientific notated form because 8 does fall as a coefficient between 1 and 9.99, between $1 and $9.99. But what do negative exponents actually mean? Well, if we were going to put this answer in standard form, it means that we would move our place values in the opposite direction. We would move to the left. And so we would have 5 place values after the 8. Now, people make mistakes here because they don't count the 8 as a place value, and you're supposed to. Because think of what $8 looks like. It's 8.00. If I was to move 5 place values in the smaller direction, a very small decimal number, I would have to go to the left, and I'd have to go past the 8 for one of those place values. Then I'd have 4 zeros that follow it in order to fill in the rest of the place values. So there is 1, 2, 3, 4, 5. This is my new decimal number. I'm going to erase where those extra zeros were on the right side of the 8, and this would be our decimal answer. We could add a 0 in front if we wanted to, and that would not count as one of our place values of the 5 negatives that we have to include. It would just tell us that there's no ones, or no number that occupies the ones place value. So negative exponents, they are going to create very small decimal numbers. Positive exponents are going to create really large numbers. And remember that when we divide scientific notated numbers, remember that when we are dividing scientific notated numbers, we are dividing the coefficients, but we are subtracting the exponents.